All right, solving exponential equations. So, two ways of solving this given exponential equations will be presented in this short video. So, 3 to exponent x plus 2, take away 3 to exponent x is equal to 216. So the challenge is to find how much is x. So the one method that we'll go over first is by using a common base. So the challenge is to observe that this and that exponent is represented by the same base. Also, we need to recall that exponential law that will be applied here. So 3 to x plus 2, if you remember, it can be expressed as 3 to exponent x times 3 squared. So that allows me to express that sum of exponents as a product of two exponents with that same base. So this is why 3 to the power of x becomes a common factor. This factor and this one here are common factor. Obviously, if you express the first term as that very product. So take out 3 to the power of x, and you have 3 squared from that portion minus 1 from here. So this is why you see this statement 3 to the power of x outside of brackets times 3 squared minus 1. Moving down. Ta-da! So 3 to the power of 2 is 9 minus 1, so this is pretty much 8. So this is why you see this as 3 to x times 8 is equal to 216. So find 3 to the power of x by dividing 216 by 8. So when you divide it, you see that 3 to the power of x is equal to 27. And now by inspection, you can solve it for x, because x is equal to 3. Expressing 27 as an exponent of 3 then further down allows you to equate the exponents, and this is why the result to this equation is that x has a value of 3. So that's method number 1. The second method, they say using logarithms. So the initial stages of the solution will be the same, right? So we do compare identical statement right here. Take out 3 to the power of x. There you go. The next step, again, similar. Find 3 to the power of x as a solution to that equation by dividing 216 by 8. Now, solve this equation for x. This exponential equation right here, solve it for x by using logarithms. Wow. Okay. So let us go back and recall the following relationship between exponent and logs. Log to base b of a is equal to c only if b to exponent c is equal to a. So this is the relationship between logs and exponents. So to find solution to that equation, we will use logarithms. Okay. So apply logarithms to both sides. So here you're just thinking of log and log 27. Maybe I'm going to erase this and do it at the bottom. Okay, already. So you would log both sides of that equation. So this is why you see log 27 as the next step. Now, simplifying logarithms. That exponent x is taken outside to give you the product x times log 3 is equal to log 27. So this is the next step. Now we have to find x. X is found as a division of this number divided by log 3. In the process of division, you get the same solution. And you always must check if that does work. By inspection, you would say 3 to 3 plus 2 minus 3 cubed should give you, and you do the calculations, 216. There you go. So this is how we solve that exponential equation using two different methods. They were almost identical to the same till this step was considered. And then we used no logarithms, and then we used logarithms, and the answer is the same. Okay, now these two questions here. Solve for x giving the following. So that equation has two different bases. The exponent, the base is 4, and on the other side, the base is 16. Preferably, and most of the time, you will be able to express one base in terms of the other. So 4 squared is equal to 16. So this is why you see this expression 4 squared in brackets to exponent x minus 2. And the next step will be to apply the rule of exponents, which simply means multiply 2 times x to get 2x, and 2 times negative 2 to get minus 4. So now we have two parts of this equation with identical base on both sides. So the left side is equal to the right side only, and only if the exponents are equal, since the bases are the same. So this is why the next step is just to equate the exponents, because the bases are the same. So simply you can say we drop the base. That can only be done when the base is identical on both sides. So this linear equation, you have to rearrange that by moving x's to one side. So x minus 2x gives you that. Keep that constant, and then one more step, solve it for positive x, therefore x is 4. Ta-da! Done. Question C. So 1 over 2 versus 1 over 4. Two different bases. However, by the following observation, 4 is equal to 2 squared. So we can manipulate these two fractions and express them as power of 2. We call negative exponent rule. A to negative n exponent can be expressed as 1 over a to exponent n. Very important rule. So changing 1 over 2 into this base 2, changing 1 over 4 into that base 2 exponent. So 2 to negative 1 and 2 to negative 2. Now the distributive law. We will multiply negative 1 by 4x plus 1, and also we will multiply negative 2 times 3x plus 3. So this is why the next step shows these two exponents. -1 and 4, -1 and 1, -2 and 3x, and -2 and 3. So the same approach as with the question on the left-hand side, the same base on both sides, therefore equate exponents. Rearrange this linear equation, so group x terms together, then group constant values together on the opposite side, and you will find a solution for x. So -6 and 4, -4 plus 6 will give you 2x, right? And -1 combined with -6, so move to the opposite side, so you have 1 plus -6 gives you -5. Divide both sides by 2, and there you go. We have solution to this equation. That is a negative rational number. Okay, so we did 3 questions. We hardly used logarithms, and you may start thinking, so what's the point? So this question here, let's look at the one on the left side. So let's call that was C. Let's call it question D. So we have 3 to exponent x is equal 9 to exponent x plus 3. We may have to combine 9, combine express 9 as power 3. But let's not do it. Let's say I don't see it and we're not going to use that method. So the option that we have is to apply logarithms to both sides. So log left side and log the right hand side. Then the next step is to take the advantage of the exponent rule that tells you take out that exponent. So x plus 3 as 1 unit goes out. Okay, so we have to solve for x. So before you solve for x, you need to simplify. And you can simplify by first using the distributive law. Multiply x times log 9 to get this term. Multiply 3 times log 9 to get this term. So now we have 2 terms that contain x. These 2 terms we can combine together to create 1 term. How are we going to do this? So take a look. By simply moving this x log 9 to the opposite side, you will combine this and that, take out x later, so the constant value is kept on the opposite side. The next step is to factor x from these 2 terms. This is why you see x outside of brackets and inside the difference. So the right hand side, you keep it, you don't touch this. So solve this for x simply by dividing both sides by log 3 minus log 9. So finding the result of this quotient will give you x, and x value is -6. If you were to use the other method, and I really do challenge you to find a solution to this equation by just applying this shortcut that converts base 9 into base 3 and then work with exponents, and you're guaranteed to get the same, exactly the same result. So you may say, well, all those questions are pretty easy, so I can do every single question. Yes, you can. Indeed, once you know that you can use logarithms, you can solve almost every, you can solve pretty much every single exponential question. Okay, So the one on the right hand side, let's call it question E. Since the base on the left side does not equal to the base on the opposite side, there's no way that we can convert into one common base. So the only options that we have here is to use logs. So log both sides of this equation. Then use the rule of the exponent. Take out x plus 1. So you'll see that now I have pretty much identical idea as in question D. So this is exactly the same step. Then the next step will be to factor, to distribute, to expand it, not to factor. So this is why you have x log 3 and 1 times log 3. Then you're going to combine these two terms because they do contain the same variable x that you're after. So bring this to one side. You keep this term, you bring this to that same side, log 3 remains on the opposite side as a constant value. Now factor x. Factoring x allows you to simplify this further, and then by dividing, I don't know what that is, by dividing both sides by the difference log 2 minus log 3, we'll get the answer. So in this case, the solution is not a definite number, so it's approximated. So not always you will be able to find roots that are definite values. Oftentimes you will be working with a question where you have to find with a certain approximation. I hope you have enjoyed this video. If you have any questions, please do ask right below that video or post a comment. Thank you very much for sticking around. I see you next time.